Creation science refers to a scientific theory or approach that attempts to explain the origin and development of the earth and life from the perspective of Christian creationism. Theoretically, creation science posits that all living beings and the earth were created by a single creator, namely God. It seeks to explain the origin and development through scientific methods based on Christian interpretations of creation. However, the key distinction from conventional evolutionary theory is that creation science typically starts with religious beliefs and attempts to establish hypotheses, but it does not subject these hypotheses to scientific evidence and testing. Instead, it seeks to assert existing creationist beliefs as scientific theories, which has led to criticism and rejection by the majority of the scientific community. As a result, creation science is widely regarded as unscientific and academically discredited. Scientific methodology relies on falsifiability, adherence to natural laws, and evidence-based approaches to explain and understand phenomena. Evolutionary theory is widely accepted as a foundational principle in modern biology and earth sciences, while creation science is considered to be inconsistent with scientific methods. Consequently, creation science is deemed unscientific and academically discredited by the scientific community. Radiometric dating and carbon dating are two different methods used in geology and archaeology to determine the geological eras and the age of organisms. Radiometric dating. Radiometric dating is a widely used technique to determine geological eras and periods. This method relies on the property of certain elements known as radioactive isotopes, which undergo random decay in rocks and minerals, emitting radiation. This radiation affects the crystal structure within the rocks and leads to changes in the ratio of atoms and isotopes. The commonly used radioactive isotopes for radiometric dating are uranium, thorium, potassium, and others. These isotopes decay into stable isotopes at a fixed rate known as the half-life. By measuring the change in atomic ratios and isotopes within rocks, scientists can determine the time when the rocks were formed. Carbon dating. Carbon dating is primarily used to determine the age of periods after the geological eras and organisms that lived during those periods. This method involves measuring the carbon-14 isotope in organic materials such as bones, seeds, wood, and skin remains. Carbon-14 is produced in the atmosphere of the Earth by cosmic rays, and living organisms maintain a constant ratio of carbon-14 while they are alive through respiration and consumption of food. However, once an organism dies, carbon-14 production ceases, and the existing carbon-14 begins to decay. By measuring the ratio of carbon-14, scientists can estimate the age of the organism and the time since its death. Both radiometric dating and carbon dating are valuable tools in geology, archaeology, and scientific research. They play a crucial role in understanding the Earth's history and the evolution of organisms. Half-life refers to the time it takes for a radioactive isotope to decay and reduce its quantity by half. Radioactive isotopes naturally decay into more stable isotopes through a random process, emitting radiation in the process. Each radioactive isotope has a unique half-life, representing the rate at which the isotope decays. It is an important constant that allows us to understand the decay rate of a radioactive isotope. Half-life means that over time, the quantity of the isotope reduces by half, and scientists can use this characteristic to determine the age of radioactive isotopes. For example, the half-life of uranium-238 is approximately 4.5 billion years. This means that uranium-238 will be reduced to half its original amount every 4.5 billion years. After 4.5 billion years have passed, half of the original amount of uranium-238 will remain. By measuring the ratio of radioactive isotopes inside rocks, scientists can estimate the time when the rock was formed and its age. Similarly, half-life is used in dating ancient organic materials or archaeological artifacts. Since each radioactive isotope has a different half-life, it is essential to consider the appropriate half-life for the specific radioactive isotope used in dating to obtain accurate results. This allows geologists and archaeologists to gain valuable insights into the Earth's history and the evolution of organisms.